ኦኬ ውድ ተማሪዎቼ እንደምን አላችሁ? ያው ባለው ወቅት ሁኔታ ምክንያት ፊት ለፊት ተገናኝተን መወያየትም መማር ማስተማርም አልቻልንም። ይሄ ነገር ሳይንስ እና ቴክኖሎጂ ትምህርቶችን ለመስጠት እንዴት አስቸጋሪ እንደሆነ እናንተ የሚያያችሁት ይመስለኛል። ፓወርፖይንት መላክ ቨሪ ሲምፕል። ኢቨን ኖቶችን ብቻ መላክም ሳይሆን መጽሐፍም ልኮ እንድታነቡ ማድረግ ይቻላል። ግን ካን ዩ አንደርስታንድ ኢዝሊ አዳዲስ ኖሌጅ አይዲያዎችን ስትማሩ ሁልጊዜ አስተማሪ ድጋፍ ያስፈልጋል። መሰረታዊ ነጥቦችንም ፊት ለፊት የመጠየቅ የመረዳት እድሉ ይኖር ነበር። ግን ካለው ተጨባጭ ሁኔታ ይህም ማድረግ አልቻልንም። እንግዲህ ፓወርፖይንቶችን በተከታታይ ልካለሁኝ። ነገር ግን እናንተን እንዲያግዛችሁ ደግሞ ትንሽ ቪዲዮዎችን እየቀረጽኩኝ በተለይ አንዳንድ ቴክኒኮች በጣም ቴክኒካል የሆኑ ጉዳዮች ሲኖሩ እንደዚህ አይነት እየቀረጽኩኝ እልክላችኋለሁ። አዲስ በከፈትኩት ጉግል ክላስ ላይ እየገባችሁ ቼክ ማድረግ ነው። በነገራችን ላይ እሱም ብዙ ጊዜ ቼክ ማድረግ አለባቸው። አንዳንድም ሪዲንግ ማቴሪያሎችን ቪዲዮዎችንም እዛ ላይ ነው ፖስት ማድረግ። እስካሁን የላኩትንም ያያችሁት ይመስለኛል። እንዲህ እያደረግን እየተረዳዳን እንቀጥላለን። ሌላ አማራጭ ያለ አይመስልም። So today we will start. I want to show you how to determine band gap using origin, especially when you see the PowerPoint. There are two techniques. One is the Tauc plot. Of course, I remember I have sent you a video how to determine band gap using Tauc plot, of course using origin, but I can include it also today. And the other one is a derivative approach. So we'll see in short. For illustration, I want to use the UV's absorption spectra of zinc oxide nanoparticle. So first I open the raw data using origin. Open the raw data. This is the raw data that we have. This column is this, and this column B is for absorbance. Then open origin. You have to install origin any type, but now I am using origin 2019. This is my origin. It doesn't make any difference. You can use any type of origin. Then go to the Excel, copy the data. We want to see the picture. Copy. Then come to the origin and select one cell, just one cell, and then paste. As you can see, this column is nanometers, that means the wavelength, then this one is absorbance. So let's see how it looks like the UV spectra. Select the X and the Y, and then the type of the plots. I want to plot line in the symbol. What it looks like, I want to see the UV spectra itself. This is the raw data. You know, when you do experiment and collect the raw data, there could be some errors. Yeah, as I expected. Here there is one data point which is around wavelength of 203, absorbance of 8, and here there is also another one. So these values are erroneous. They are actually unexpected or errors. So let me remove to smooth this window. Let's go to the datasheet book. Go to window, then select book. This is the datasheet. One is here, 8 absorbance. As you can see, it is very exceptional, around 200 and 201 and 203. These are errors. And the other one is 249, around 249. Let's go down. Wavelength of 249. Here is 249. As you see, this is very exceptional value. Now let's see the plots. Let's go to window, then select the graph. You can see the window in the graph in the window section. You see now the graph looks like normal, but let's rescale. Go to the graph and rescale to show all. Press this one. Yeah, you see this very nice plot. This axis is, of course, it's not P, so I have to change. This is the absorbance, A, and the x-axis is the wavelengths. So usually we represent the wavelength by lambda. Let me use the Greek letter here. There are Greek letters. Press this one, and when you press L, it becomes lambda. Then remove the Greek letter and indicate the unit. It is nanometer. The unit of absorbance is arbitrary units. There is no unit for absorbance. So this is a normal UV plot. As you can see, the maximum wavelength can be checked by screen reader. Yeah, the X value indicates that 668 nanometers, that is the maximum wavelength. Well, our objective is to calculate the band gap from this the UV spectra. So let's go back to the original sheet. First, let's practice the Tauc method. So in the Tauc method, normally what you do, you have to plot, you have to calculate the energy and and convert to alpha h nu square. This is indirect band gap, so the value is 1 over 2. 1 over 2 over 1 over 2 is the power becomes 1 over 2. So let me add first column, add a new column. So this is a new column. I want to calculate the energy here. Click the column and right mouse. Set the column values of this column is C. Here it comes. So column C equals to, you have to write here, I want to be the column C to be energy, that means 1240 divided by wavelength, as you have seen in the slide, over the wavelength. The column of the wavelength is in the column of X, so over column, which one is the wavelength that contains is column A. So 1240 divided by column A. Column A is wavelength, that is equals to the energy. As you can see, the energy is calculated. The next, let me add another one, add another column. So another column, I will say to calculate this one. If you remember, alpha h nu square. So let's select this column, set the column values. So column D should be bracket, if you remember, 2.303 times the absorbance. Absorbance is column B times column B times the energy. Now the energy is column C, then column C, all the power. So you have to use carat. This carat is power, the power of 2. So that is the square or coil of alpha h nu. Now, so we have here the energy column and this one. But in the Tauc plot, you have to plot this versus this. So this should be x. So set this value, select the column and set as x value. You see it becomes x, x2 and y2. So plot this one as a line and dots. Yeah, it becomes something like this. We are interested around the peak area around here, so we can select this area by scaling in. So let me take this part, only this part. You see it rescales. So the tangent line should be this one. Let me take a line here. This is the line. What will be the value around here? This is the tangent line, the tangent line, which we are interested in the Tauc plot. So let me check by using screen reader. This value is 3.29. So let me write it. Take the text, the band gap, Ag, using Tauc plot for zinc oxide nanoparticle. particle, it becomes 3.29, and this axis, x-axis, is energy plus, that is electron volts. So this is the Tauc plot. You have to remember this one is energy, this is H nu plot, and the unit becomes electron volt, and the x-axis is not d, but it should be in the bracket alpha so it is alpha h nu the power of 2 that is the unit is arbitrary unit. So that is the Tauc plot, and we have determined easily the band gap by this procedure. Now I want to use the derivative, so let's go to the book, to the data point. Here come again. So let me add another column. So now I added another column. So the derivative form, that is the derivative of the absorbance versus energy. So we are interested in the absorbance versus energy. So the absorbance is this one. Let me copy this one, copy, and paste here. Copy the value, and let's go to this one and paste. So this is the same thing with the absorbance. Column B and column is the same. So I want to derive this one with respect to energy. Energy is column C. So what I will do, select this value, go to the analysis, mathematics, differentiate, open dialog. So here comes, click the input. So the input says that x is C, that means the energy, y is E, that is the absorbance, the derivative of E with absorbance versus column C, that means the energy. That's okay. Or derivative order 1, smooth, click the smooth, and click the one which is Zawadzki-Golay smooth with click, then go to the plot derivative curve. Yes, of course we need the plot. Then say okay. Plot, as you can see, this is the derivative part, and this one is the energy part. This is energy, H nu, that means, in other words, so the energy in the unit of electron volt, and this one is the derivative. Let me change. This is the, so this is dA over dE, derivative with respect to energy. This is a derivative plot, but where is the value we are interested in? Is somewhere here in the maxima. As you can see, it's almost the same value. It is almost the same value, so let me write it. So based on this, the energy of the band gap equals to 3.29 electron volts. Because when I click here the screen reader, the x value reads 3.29. X value means the energy in electron volt. That is the band gap of zinc oxide. nanoparticle. In this way you can determine. Well, I have used the UV spectra of zinc oxide nanoparticle. You can take the UV spectra that I have plotted in the Google Google class. There are also I have given you in the Google class, so download those values and practice. So I will give you also exercise with those values. Thank you.